Okay, so we're going to be doing part 2 of our fundamental theorem of calculus lesson. We're going to start by looking at an integral of a absolute value, which we have not done before. So if I graph this function, I've got it all plugged in here. I've got the absolute value of 2x minus 1. So I'm going to draw a sketch on my paper of this. And I'm going to go from 0 to 2. So it looks like we're going to have this little triangle over here plus this triangle over here. So the problem with this is that technically when you have an absolute value, you've got two equations going on here. So that's why we can't just use our properties of adding and dividing. So this equation, this line over here is the 2x minus 1. But this one on the left side is negative 2x plus 1. If you remember back to Algebra 1, when you solved absolute value, you had two equations always so that you could get all of your answers. So what we're going to do is we're going to set up two integrals. The first triangle is under this first expression, negative 2x plus 1. And I just need my boundaries. So it starts at 0. And if I want to know where it crosses or it touches the x-axis, I would just take my 2x minus 1 equation, set it equal to 0, and solve. So that means it crosses at 1/2. My second shaded region goes from 1/2 to 2, and that equation is the 2x minus 1. Okay, so now we're just going to solve these separately, just like we did when we did the definite integrals on part 1. So I'm going to take my integral first. I'm going to add and divide. So that would be negative x squared plus x, and we're going to evaluate from 0 to 1/2. Over here, I'm going to take the integral. I'm going to add and divide. So that's x squared minus x, and we're going to evaluate that from 1/2 to 2. So now I'm going to do my top minus bottom. I'm going to plug in 1/2 first, minus, then I'm going to plug in 0, over here I'm going to plug in the 2 first. So I'm adding my two areas together. So 2 squared minus 2. Minus, then I'm going to plug in the 1/2. Now, if you want, you can plug all of that into your calculator to get an answer, or you can solve them each a little bit separately. So here I have negative 1/4 plus 1/2. That's just going to be 0. So plus 4 minus 2 minus 1/4, and that would be plus 1/2. So that would be negative 1/2 if I combine those negative 1/4, plus 1 if I add the 1/2, plus 2. So 3 minus 1/2, so that would be 2 and 1/2. So unfortunately, there's no simple ways to do an absolute value. You have to kind of see where they touch the x-axis to split it up into the two graphs, and then set up your two integrals from there. So for the rest of this lesson, we're going to talk about some important theorems. One is called the mean value theorem for integrals, and it's basically a concept that we talk about. So let's say you have an integral. So down here in the diagram, I'm going to draw a diagram. I'm going to make a nice curve. And let's say I'm going to go from A to B. I just want to look at that region between A and B. So all the mean value theorem says is that if you have a shaded region, there is going to be some rectangle that will give you the same area as that shaded region. Now, I'm going to draw a rectangle right about here. If I were to find the area of that rectangle, that would actually be pretty close to the actual area under the curve. So that's all that theorem states, is that there is some rectangle equal to the actual area under the curve. So up here, this diagram here, this is our actual area under the curve. And this right part represents the area of our rectangle. So this is just our height, f of x or f of c, and this is our base of our rectangle, subtracting the a minus the b. So that's just a concept that you might hear about in Calculus 2, that they might say the mean value theorem for integrals. It's just a concept. It's not something that you're going to have to solve. So let's go to the back. Let's talk about another theorem. This one is called the average value of a function, and it's pretty easy to do. It should make a lot of sense, actually. Average value is once you take the integral, right? That's our integral, or our area under the curve. We're then going to find the average of that. So when you talk about average, like in Algebra 1, the average, if you think about an average, means you're going to add up your total, right? And divide by how many numbers you were dividing by. So I'll call that n. So basically that's what we're going to do. The total is our integral. Right? That's an infinite amount of rectangles that we're adding up. And that gives us the total area under our curve. But if we want to find the average area, we're going to divide by how many we added between. So if we're going from A to B, we would find that distance. So we would subtract B and A, and that would tell us the distance that we're going in between, and that's what we're going to divide by. So that's where this 1 over B minus A comes in. B minus A is your distance. So we're going to divide by that, and that'll give us our average value. So everything else is going to remain the same. So let's actually look at number 2. We're going to find the average value of f of x equals 3x squared minus 2x on the interval from 1 to 4. So we're going to set up an integral. We're going to go from 1 to 4. And my function is 3x squared minus 2x. And the average, right, we're going to divide by how many we had, the distance. My dog just went racing through. So we're dividing by 3, right? The distance between 1 and 4 is 3. Okay, so sorry if I got a little flustered there. My dog went running through the notes. So again, the average would be the distance between 1 and 4, which is 3. So when I'm done finding my integral, I'm just going to divide by 3. So I'm going to just leave that 1/3 out in front and carry it down. But I'm going to take my integral just like normal. I'm going to add and divide. So if I add 1 to 2, I got 3, and divide by that, I got x cubed. Over here, if I add and divide, I got minus x squared. Okay, and I'm going to evaluate from 1 to 4. So again, I'm going to keep bringing down that 1/3. And I'm going to do top minus bottom. So I'm going to plug the 4 in first. 4 cubed minus 4 squared. And then minus, now I'm going to plug the 1 in. 1 cubed minus 1 squared. Okay, and now I'm going to solve. So 4 cubed minus 4 squared. So I'm going to figure that out. 4 cubed is 64 minus 4 squared is 16. So that gives me 48. Minus 1 cubed minus 1 squared is just 0. So that gives me 48, and now I'm going to divide by my distance, which is 3. So 48 divided by 3, that gives me 16. So while 48 is the actual area under the curve, the average value would be 16 because we would divide that by 3. So what that means is that for each inner increment, which is 1, each little rectangle would have an area of 16 if we spread that out over the distance of 3. Okay, so that's the end of part 2. Feel free to go back and rewatch anything. Email me if you have any questions.